Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you to the third lesson of physics for class 9. The topic for today's lesson is measuring unknown weight using the principle of moments. You studied the principle of moment in last lesson, and we stated the principle of moments as a body is said to be balanced at a point of pivot if the sum of clockwise torque is equal to the total sum of anti-clockwise torque. We can use this principle to find any unknown weight of an object. And by weight we mean the force with which Earth pulls an object towards its center. There is a difference between weight and mass. So we are talking about weight. And if we want to find out mass from the weight of the body, we'll divide the weight by small g, which is the gravitational acceleration, which is 10 meter per second square in for your class, but actually it is 9.8 meter per second square. But in class 9 and 10, for your simplicity, you will take it 10 meter per second square. But that's not the topic right now. The topic is measuring unknown weights. Let's see how it is done. So you see, physics is very simple. You don't need to wait for your schools to get open for performing physics. Here is a very simple experiment using a duct tape and a steel ruler to verify the principle of moments. Now let us suppose we have 3 tiny cars. We know the weight of this red one and we know the weight of this blue one, and we want to calculate the weight of this gray car. First of all, considering this duct tape as a pivot on which this steel ruler can rotate, what I have done is that I have placed these cars in such a way that the total torques on either side are equal. So they are balanced, they are not falling. This blue car and this red car, they are producing clockwise torques about this tape. And this gray car, it is producing an anti-clockwise torque about this tape. And since they are balanced, they are in equilibrium, they are not moving at all. This means that the total clockwise torque produced by these 2 cars is equal to the total torque produced by this gray car. Now, measuring the center of the scale which is on the tape, it is 17 centimeter. We consider it as the center. We can measure the distance of this blue car, the center of the blue car, from 17. That will be the moment arm for this car, and we can find the torque produced by blue car. Similarly, this is the moment arm for red car. This is the moment arm, and we know the weight of the red car, so we can find the torque produced by red car. We know the moment arm of the gray car because we know the length, the distance it has from the center, from the pivot, but we don't know the weight. We can use the principle of moments by saying that the total torque on the left side is equal to the total torque on the right side, and we can find the weight. Let's do it mathematically. The 3 cars in a block diagram, and we assume that this is the duct tape on which we have a steel rule. This is the red car, this is the blue car, and this is the gray car. Now let us suppose that the weight of this red car is 2 newtons. This is not the actual weight. This is what we are supposing. Let's first call it W1. This is W2. This is W3. And the moment arms of these weights, the center of these weights to the center of the pivot, let's call it R3, the moment arm of W3. Then the moment arm of W2 is R2 and that of W1 is R1. So according to the principle of moments, sum of clockwise moments should be equal to sum of anti-clockwise moments. So what will be the sum of clock? We have already discussed that moment also means torque. So these are W1 and W2 are producing clockwise moments. The red and blue cars are producing clockwise moments. So the sum of clockwise moments will be W1 into moment arm R1 plus W2 into moment arm R2, and this should be equal to and sum of anti-clockwise torques. So there is only one anti-clockwise torque, which is W3 weight, which is force. The only force in this case is weight. Moment is force into moment arm, and in this case the force is weight. So W3 into R3. Now I assume that the red car has a weight of 2 newtons. I assume that the blue car has a weight of 1 newton and W3 is unknown. Then I consider that R1 is, now in our case that was a steel scale, and the steel scale was the unit was of the length of steel scale was in centimeters, but since we use SI unit, it should be in meters. So we assume that the moment arm for W1 is, let us assume it is 0.5 meters. Similarly, we assume that R2 is 0.2 meters and R3, let us assume that it is 0.6 meters. Now these are pure suppositions, they are not actual readings. Please keep in mind, we used a steel scale, but the lengths we are taking is our assumptions, they are not the real readings, just for the case of simplicity. Now putting the values, W1 is 2 newtons, R1 is 0.5 plus W2 is 1 newton, R2 is 0.2, W3 is unknown and R3 is 0.6, so it will be 0.6 W3. Now if we solve this equation for the unknown, which is W3, 2 into 0.5 will be 1. 1 into 0.2 will be 0.2 is equal to 0.6 W3. So W3 will be 1.2 divided by 0.6. So W3 will be 2 newton. 1.2 divided by 0.6 is 2. So we have found the unknown weight to be 2 newton using the principle of moments. A very common example of using principle of moments to find unknown weights is the use of a physical balance for measuring unknown weights. You must have seen many shopkeepers using such a balance, a beam balance or a physical balance. In this balance, on one side the unknown weight is placed, and the unknown weight can be anything. Let us suppose that it is a cup, and on the other side we place a known weight, and we keep placing and removing weights with larger or smaller size till the time this lever becomes horizontal, which means that both the weights are now equal. Considering this point to be the point of pivot, these weights, the known weights, are producing a clockwise torque, and this cup is producing an anti-clockwise torque. So, since the torques are equal and the moment arms are equal, moment arms are equal by default. So now just by changing these weights, we can find the weight of this cup. So I hope today's topic is clear to you and you can now find unknown weights using the principle of moments. Let's proceed to the thought of the day. Allah gives us trials and hardships not to make us weak, but He strengthens us through them. Thank you. Jazakallah.